One of the most important thing that you come across with the factor analysis, you don't understand what is factor analysis and why you want to do it. The factor analysis is kind of technique that you will use for scale construction and scale validation. Whenever you develop your own questionnaire or your own scale for your research thesis, you need to validate it, and for the validity you need factor analysis. And here is your topic, the factor analysis. Watch this video and listen this topic from me in a very simple, in a very fantastic, in a very smart, in a very bright way. And if you listen this with much attention, you will never, I think, I'm not exaggerating, you will not forget it. Factor analysis is of two types. One is exploratory factor analysis and one is confirmatory factor analysis. Factor analysis is of two types. One is exploratory factor analysis and the second one is confirmatory factor analysis. Exploratory factor analysis is represented as EFA, while confirmatory factor analysis is represented as CFA. As the name suggests, exploratory factor analysis. The word exploratory means that you will explore how many items and how many factors you will explore in literature review. You will go to literature review, you will dig deep in literature review and you will explore factors and items for your scale, for your questionnaire. So for example, if you found 4 factors and 40 items from the literature review, it means you explored 4 factors and 40 items from the literature review. Now what you will do? You will go to the data field, you will go to the field, you will go to the practical field, you will go to the participant, you will go to the sample, and you will give your questionnaire to them and they will fill it. And try to divide your sample in 2 parts, first half sample and second half sample, first count of the sample and second count of the sample. For example, if you filled your questionnaire from 400 participants, so from 400 participants you filled your questionnaire, so the first half of 400 means 200 and the second part of 400 means second 200. So first 200 students and second 200 students. Your 400 students is composed of 2 groups, first 200 students and second 200 students. You will, the first 200 students, you will use those first 200 students for exploratory factor analysis and the other 200 students you will use for the confirmatory factor analysis. Make this point clear. The first 200 students you will use for exploratory factor analysis, while the second 200 students you will use for the confirmatory factor analysis. So now, after deciding 200 students for the exploratory factor analysis, you will put the 200 students data into SPSS software. You will put 200 students data into SPSS software. SPSS stands for Statistical Package for Social Sciences. When you put the 200 students data into SPSS software, you will go to analyze option. The option is analyze. You will go to the command which is called analyze command. You will go to the command which is called analyze command. After click of the analyze command, you will go to dimension reduction. You will go to dimension reduction. The first command is analyze, the second command is dimension reduction, and the third command is factors. So on SPSS, you need 3 commands to run the exploratory factor analysis. The first command is analyze, the second command is dimension reduction, the third command is factors. When you run these commands, then you will come across with the very first table. After you run this exploratory factor analysis, you will come across with the very first table. The very first table is called KMO table. KMO means Kaiser-Meyer-Olkin test. KMO means Kaiser-Meyer-Olkin test. This is a type of test which tells you whether your sample is enough for EFA or not, whether your sample is sufficient to run exploratory factor analysis or not, whether your sample is okay for exploratory factor analysis or not. If your KMO value is equal to 0.6 or greater than 0.6, it means your sample size is enough, your sample size is sufficient. But if the KMO, Kaiser-Meyer-Olkin test and Bartlett test of sphericity value is less than 0.6, it means your sample size is not enough, your sample size is not sufficient. After the KMO test, you come across with the next table. The next table is called communalities table. And the third table, which is very important table, it is called total explained variance table. The third table is called total variance explained table, and I will tell you what is total variance explained table. But again, just to recap, when you make your questionnaire, you go to literature review, you explore the items and factors from the literature review, then you make the questionnaire. After making your questionnaire, you go to respondents, you collect data from respondents, then you divide the respondents into 2 parts, first part and second part. The first part of the data will be used for exploratory factor analysis. The second part of the data will be used for confirmatory factor analysis. As name suggests, exploratory factor analysis means to explore the factors and items, and confirmatory factor analysis, as the name suggests, confirmatory means to confirm the factors and items. After you put the first half of data on SPSS software, you go for the first command, which is called analyze, then the second command is dimension reduction, then the third command is factors. After you run the factors, the first table that you come across is Kaiser-Meyer-Olkin table, KMO table, and its value should be equal to or greater than 0.6. And then the second table is communality table. Then the third table is total variance explained table. The total variance explained table tells you much of the information, and in the total variance explained table, the value should be 40%, 40. The minimum total variance value should be 40%. If it is less than 40%, it means your factors and your items are not good. But if the value of the total variance explained table is greater than 40, it means you are going in the right way. Then you come across with the matrix table, and the last table is RCM, rotated component matrix. RCM, R for rotated, C for component, and M for matrix, rotated component matrix. The rotated component matrix should be the last table of your exploratory factor analysis. The rotated component matrix RCM should be the last table of your exploratory factor analysis. I hope you understood this very simple lecture. If you have any question, please share in the comment box. I will answer your questions, and save this video for your thesis, and also share this video with your friends. You know, one thing, I take a lot of effort to make this video. Thank you so much.